Hi, I'm Kate Lawrence Gupta, and I'm currently the principal engineer for Splunk at Comcast. I work in the technology and product division, which is responsible for the X1 platform. My main responsibility is to manage several Splunk installations that are extremely large and distributed, which means that we're always on the lookout for ways to expand, whether this means new bare metal or, in many cases now, cloud providers. Well, moving into new cloud providers means that I needed a way to test how Splunk would work in those particular providers' data centers. So I needed a way to measure how Splunk would perform. Gladiator started as a series of scripts that would measure CPU utilization, memory, and disk I/O. But now it's grown to be a complete application that will both produce data in a randomized fashion to disk, measure that data ingest up to the minute if you want to, and actually create artificial search loads so that you can pretty much create a simulated Splunk environment and determine how your box is going to perform. I'll walk you through a demo of how Gladiator works. Let's do an overview of Gladiator. You log in with the default username and password, admin Gladiator test, and it drops you right into the application here. Gladiator can be loaded from the left-hand side, and these are your test results. This includes your system information, your SAR, CPU statistics, and your VM or memory stat statistics in megabytes. Additionally, you can see IO stat data collected in megabytes for all volumes on the system that have been attached. This gives you reads and writes. I captured index size statistics and search job statistics from the introspection and REST API endpoints to give an overview of how much was being written and read to disk. Disk rates and disk stats are converted to blocks per second in order to be compared to SAR-D. Additionally, we can go and look at the macros that are driving this dashboard under the advanced search option. And this is where all the calculations are happening in the background. This includes the calls to REST services, the indexes that hold that data is called perf stats, and what the calculations that kind of occur in there. If we look at the data input section, we can see a list of all of the scripts that are running that help collect this data, including Hipster, which creates the data, IO, search load, VMware, VM stats, and systats information. All of this is feeding data to the perfstats index, is what we saw before.